Hi, welcome back to Devops training tutorial. So let's discuss about second topic in this Devops training series, that is Docker. Before discussing about Docker, I would like to discuss about containerization that is enabled by Docker. So this is the agenda on my screen that we'll be discussing in this session. First, we will discuss about virtualization, how virtualization can be done, what is virtualization and what are the benefits of virtualization. Then we discuss about containerization in short and the features and how it adds value to our deployment when we use containerization over virtualization. We will discuss about some containerization tools that can be used to enable the containerization in our host machines. Then we discuss about major containerization tool, that is Docker, which is very popular among all the organizations and in public. And we will see what Docker lifecycle it follows. Then we discuss about various components of Docker ecosystem that help enabling Docker services and run containers on your machines. We will see a small demo on installing Docker. Once Docker is installed, we will check on running some Docker commands that are very useful to run containers and manage them on your virtual machines. Also, we will look around Docker Hub repository, which is a publicly hosted Docker repo to maintain container images publicly by Dockering, where you can register and create your account in order to make your images publicly available so that you can download and run your containers anywhere. Then we will see how we can make changes to a running container and save them for future use. These committed images, container images, or created images from a Docker file can be pushed to Docker Hub also. We will see into it as well. We will also see Docker file, how we can create our own Docker file that gives virtual environment for application hosting, and even developers can use Docker files to write the environment in terms of Docker images, and they can publish them along with their code to testers or release teams so that they can easily deploy the applications developed by the developers. Also, we will see once we have developed our Docker file, a small sample Docker file we will develop and try to run it and test the services that we use to run with this Docker file image. So let's discuss about the first topic, what is virtualization. Virtualization is the process of running multiple virtual systems or resources on top of a single physical machine. These resources could be storage device, network, or even an operating system. So whatever we have as physical resource in our data center, we can virtualize them. Before a decade, we used to hear about more about physical machines, physical servers, where we used to run our applications. But later, when virtualization was introduced, we used to install hypervisors on our machines, on our bare metal machines or host operating systems. Based on the type, we have two type of hypervisors. One is type 1 and type 2. So based on the usability, both the type of hypervisors are available. The major motive of these hypervisors are to provide virtualization on top of the base operating system or base machine. So like ESXi, we have heard about, which runs on bare metal machine and provide a virtualization layer of the hypervisor to host various virtual machines. Similarly, we have VirtualBox, Oracle VirtualBox, right? We have VMware. These all are vendor software which support virtualization, and these can be installed on running host operating system so that they can enable virtualization on top of my host operating system, and the resources running on available on host machine can be used by virtual machine to run services by dividing the resources into required specified numbers or specifications. So suppose we have a machine, bare metal machine of or a host operating system of 64 GB host OS, right? We can install a hypervisor. We can use virtual machine, VMware. Okay. Install hypervisor, which will create a virtualization layer and enable the virtualization, and on top of which I can create my virtual machine. So guest OS, VM1, VM2, VM3. Now the resources that they can use can be specified, like it can use 12 GB, it can use 10 GB, and it can use 10 GB. Total it becomes 12 and 22, 32. Rest 32 is still safe. We should be leaving some good amount of resources for host operating system also to run the services and host the virtual machines, and rest we can divide among the virtual machines so that they can run and provide optimum and maximum utilization of the host resources, saving cost. So that's why virtualization is very famous among the industries, and almost everywhere now we see virtual machines are used to host services. And on top of virtual machines, you can run your app, and they will be completely segregated. They will treat their guest OS as an independent machine, and they will be completely isolated from each other, despite of running on the same host operating system. So this is the concept of virtualization that can be used to manage services efficiently and resources in cost-effective manner. So this is all about virtualization. Next topic we discuss about containers and containerization in next session. Till then, keep Hi. So let's see what containerization is. In last topic we discussed about virtualization. So we'll see how containerization can benefit over virtualization. So what is containerization? Application containerization is an OS level virtualization method used to deploy and run distributed application without launching an entire virtual machine for each app. This means we have virtual machines, and on top of it we are creating OS level virtualization using containerization. From Linux 7, means Linux Red Hat 7, Ubuntu 16, and Windows 8, we can say. Windows 7 or Windows 8. Virtualization, containerization concept came into the picture. Linux actually added a feature called namespaces and cgroups. These two important concepts were enabled and introduced by Linux operating system developers to support the containerization. Whenever we create containers, they use OS namespaces. And using namespaces, the resources are divided into various containers, or we can say they are segregated from each other. So every container that is deployed C1, C2, C3, C4, they are deployed in different namespaces. Okay, so the concept of namespaces actually helped containerization come into picture. So this actually, once containers are created, they are very lightweight. If we compare containerization and virtualization, in virtual machines, we were installing a complete binary of the operating system, whether it is Linux, Ubuntu, Red Hat, Windows. For every OS that we installed, it was complete package. That was in GBs. 700 MB, 1 GB, 1.5 GB. If we look into today's date, one operating system is of average size. If I talk about ISO image, binary image, it is of on an average 1.5 GB of size. And once it expands, it occupies around 5 to 10 GB of space on your operating system, on your disk actually. So that's why installing complete operating system in virtual machine was occupying a lot of resources in terms of disk space, CPU, and memory as well. So containers actually, in virtual machines actually, a lot of the things by libraries, binaries that we install as part of the complete operating system were of no use. Suppose I am deploying a web server, an application server on my host machine. So I will not be using many services. I will be just using few ports, right? Few networking components and some of the CPU and some of the libraries of the OS. Maybe if my code is my application is Python, so I will just using Python libraries that will be helping my applications to run Otherwise, if we have Java installed, .NET libraries installed, these are of no use. So what containers help, they actually remove the unnecessary component from the OS image and they just installed binaries and libraries. If you see here, we have operating system, we have hardware, operating system, container engine. Container engine actually enables containerization on top of my operating system. Operating system can be a virtual machine or physical machine, both you can install container engine. So once you create containers, they are not using complete binary of operating system or not complete or ISO image of any operating system. Now container images actually use the required binaries and libraries that are needed to run the application hosted on it. Apart from it, the containers concept removes all the unnecessary things from the OS that you are going to deploy as a container. So this is the major difference. So from 800 MB or 1.5 GB, our container images size are drastically reduced. So from 1.5 GB, we see our container images of size 30 MB, 40 MB, 50 MB, which is a quite good amount of improvement that we can see, and they can be easily transferred from one place to other for deployment purposes. They can be used in pipeline, they can be used in automation, they can be downloaded over internet. Now you can imagine downloading 30 MB as compared to 1.5 GB image is very much faster and less cumbersome. It will not consume your lot of bandwidth that you need to pay over the internet when you're using cloud services, when you are using your internet service provider. So having smaller size container images has saved lot of cost and network and resources that VMs were not able to provide the efficiency. So that's where container has become very popular, and the containerization is booming a lot, and everywhere is just rushing around to migrate from VM to containers, because apart from resources, cost efficiency, they have other benefits as well that we'll be discussing in next slides. Problems before containerization. Developers when run the code on their system, it would run perfectly because they have their development environment set up. Their development is being done as per the environment they have set up, and everything is as per their expectation because they know what they need as a prerequisites to run the development that they are working on. But the same code, when they ship to the testers or operating teams, they face issues because they may not have same build of the server, they may not have same configuration of the server where they are trying to deploy the code provided by the developer, and that's where it was a very common problem developers and operations people were facing in past, because the same code provided by a developer run on their system very well, and on operations side it was giving some issues. So how like the problem was the environment code. If you go in more detail, the problem was the environment code was being run well, a simple answer could be why not give the same VM. So the problem was the environment where the application is getting hosted is not actually running on the operation side because they had different VMs. So one solution was to ship the complete VM image also along with the developed code to the testing team. And as I said, the size of the VM images was in GBs, right? 1.5 GB, 2 GB. Even if you have a lot of dependencies, libraries installed, it may go till 2.5 GB or the complete VM size. If we are going to, like, we have Oracle VirtualBox image, right? .vmdk extension. So even that image, if we have installed operating system, that becomes 20-30 GB, and shipping the whole image to the operations team is not possible. It is very much time consuming, and downloading image over the internet and uploading is very much cost will give you a lot of cost also when you want to do so. So VM, the problem, if we summarize in pointers, it's like VM took too many resources to run. We all know that they were not customized as per the application. They were installing everything on a single machine. They were big in size, and hence they were not portable. Also, they were not developer friendly because developer need a prepared environment. Like they need, suppose a Java level developer needs a Eclipse environment setup, class path, Java path, everything needs to be set up to support their development, right? So these kind of problems were there while using VMs. So these problems, how can be solved using containers? With containers, all the issues were solved. How? The developers could easily wrap their code in a lightweight container and pass it to operations team. As I already said, containers are small in size. You install the layers that are actually needed to host your application. Unnecessary things are removed completely. We have a very thin layer of operating system kernel installed, that is very minimal image that you can use. And suppose you want to run Python application, you just install Python and related libraries in the container image and bundle it and ship it as a container image to the operations team. So what actually developers started to do in the practice, they started wrapping the code in container images that already had pre-specified, predefined environment in that image itself, and that operations people can simply deploy and start the services at their end in few minutes itself. So using this approach, containers provided a lot of advantages, out of which few are here. Containers are not resource hungry. They they use only resources what they need, what their hosted application need. Okay, they are lightweighted and hence portable. They are in MBs only, less than 100 MB usually. So they can be easily transferred, uploaded over the internet and downloaded somewhere else in order to host the applications. And then also they are developer friendly because they can be configured through the code, right? So everything we discussed here is just a glimpse of containerization, how containers can help over virtual machines. So these are the features we will be learning and doing in coming sessions. So as we discussed about containerization concept, we understood what containers and containerization are. We will see some tools in next session that can support containerization. Hi, so let's see what containerization tools we have available in the market. There are several container tools available, out of which I have listed three here, which are very popular among all: Mesos, Rocket, and Docker. Out of all the three, we'll be discussing Docker in detail. Any tool can be opted. These all provide these are fully fledged containerization tool that once installed on your virtual machine can give you all support so that you can run your containers and package them and deliver them to support teams in order to deploy the services. Out of the three tools, we'll be discussing Docker in detail. So let's see what Docker is and how it can be used to provide containerization to our application. Hi. Till now we discussed about virtualization and containerization and few of the container tools. Now we will see one of the very popular and strong tool that can manage containerization on your virtual machines, be it Linux, Windows, very efficiently. What is Docker? Docker is a computer program that performs operating system level virtualization, also known as containerization. It was first released in 2013 and is developed by Docker Inc. Docker is used to run software packages called containers. So till now we have quite understood about containerization, that is called OS level virtualization. Now we will see how it can be put into action using Docker. So this slide discusses about Docker lifecycle, how you can pull images. So as I already said, Docker is a public repo hosted, that is a portal running, that is a repository running on web by Docker to have a bundle of, or you can say a list of all images that are pushed to the Docker hub. And these images are actually publicly available. Anyone can register here, anyone can create their account and they can start pushing their own images. Even for pulling the images, you don't need to create account. You can directly pull the images, but for pushing the images and host your own image there on Docker Hub, you need to create an account. So once you are ready with the account, you can push and provide your images for public uses. So the lifecycle starts from pulling the image. Whenever you start or try to run any container, it will try to pull the image related to it. Because whenever you try to run a container, you provide a relevant image to it. That image, first Docker engine will try to look locally in local repo, Docker repo, if the image is already available. If not found, it will give you a message that unable to find the image locally, and it will go to the Docker Hub or any other configured repo. Instead of Docker Hub, you can create your own container repository also. Like we have various container repositories available that are managed container repositories over AWS. We have ECR in Google Cloud. We have GCR. Azure, we have ACR, Azure Container Registry. So these kind of hosted services are also available that can be used in place of Docker Hub. So the whole matter is we need to have a repo, can be private or public or managed, that we can use to push our container images and download container images that are available there if not found locally. So once Docker image is pulled, Docker it will be stored in the local Docker repo, and now this image will be the downloaded image or available image will be used to run the container that you wanted to run with the Docker run command. Once a container is scheduled, it will first go into run state. You can stop it, you can delete it. So these are three major stages of any container cycle. Okay, so they can be created, stopped and deleted, and once their objective is complete. So this is all about Docker lifecycle. In next session, we'll be discussing about various components of Docker ecosystem. Hi. So in this session, we will see about various components of Docker ecosystem that help Docker services run. Various components of Docker ecosystem are Docker Hub, that is a public repo hosted on web by Docker to maintain and manage various Docker images. Docker Engine is a core service that actually enables OS level virtualization on top of your operating system. It helps with the life cycle of your containers by starting them, creating them, managing them, and then deleting them. So Docker Engine is actually, we'll be discussing in detail in coming slides. Docker images are images and containers. Docker images are images that used to run containers, Docker volumes, Docker file, everything we discuss in our coming slides. What is Docker? Docker is a central public Docker registry. It can store custom Docker images. The service is free, but your images would be public, so that anyone can use. It requires username and password. In order to push images, you will need to create an account on Docker Hub, and then only using Docker login by providing your credentials, you will be able to push your images. For pulling, there is no credential required. Docker Engine. Docker Engine is the heart of Docker ecosystem. It is responsible for managing your container runtimes. It works on top of operating system level. So you need to have a base operating system installed. It may be Linux, it may be Linux, Red Hat, Ubuntu, any flavor of Linux supports a Docker installation, and Windows also support Docker installation by using Docker Desktop. So any operating system need to be there so that Docker Engine can be installed and started to manage your container runtimes. It utilizes the kernel of underlying OS. So for managing the containers, it will utilize the kernel of your operating system only. Then comes Docker images. Docker image is like the template of a container. It is created in layers. Any new changes in the image results in creating a new layer. One can launch multiple containers from a single Docker image. Means if you have an image available locally or Docker Hub, so you can run any number of containers out of that image. There will not be any issue. There will not be any conflict of resources. It will just used as a template to run your container. And the container started will read the template lines. what it need to have, what it will be running, what actions need to perform. As per the template, it will start and configure your container and keep it running. Or once the job assigned to the container is complete, your container can complete and get deleted also. So this is what you can package these instructions, these steps you can package in your images while you are building them. Containers. A Docker container is a lightweight software environment. So rather having complete virtual machines, in containerization we have lightweighted software environment that is called container. It works on top of underlying OS kernel. They don't have their own kernel. They utilize operating system kernel only to run their services. They share host OS volume, they share host OS networking, everything they share with the host OS, but they are segregated with the namespaces as I told you earlier. It is small in size and therefore is highly portable. They are in MBs. You can control the size. It is always advisable. You cannot put complete OS binary into a container. It will build it, but it will again be of no use because you are again building a complete OS image. That is of no use, and it does not follow the container guidelines. So containers preferably need to be in MBs, small size, so that they can be portable and uploaded to the Docker Hub, any other private container registry, or any other location. It is again created using Docker images. So in order to run your containers, you need to have a proper Docker image from which they can be started. Docker volumes. Docker containers cannot persist data. When they are running, they temporarily create a volume, or you can say a temporary storage in host, or you can say host operating system. So where they will be keeping the runtime data until they are running. Once they are deleted, they are killed, the whole data will be lost. So if you want to persist those data, suppose they are application logs, their configuration data, they are databases, tables, everything. If they are running, the database is also running in containers, so you always want to persist those data. In those cases, you can always use Docker volumes to persist your data. A Docker volume can connect to multiple containers simultaneously. They can work as an external disk. They will take part on your host operating system. They will utilize the storage of your host machine, and this mounted this mounted volume in your host machine can be shared among multiple containers. So this way, if you want to share data from one container to another, you can use Docker volume. That will be a proper way to share data between containers. If not created explicitly, a volume is automatically created when we create a container. Okay, so that is also, but that will be somewhat untraceable because it will be using a long name, hexadecimal name that will be known by the container only. Docker file. Docker file is a YML file which is used to create custom containers. Suppose you already have an image, Docker image, but you want to customize it and you want to save it for future use, or you want to install some dependencies for your application on a core Docker image. In those cases, you can include commands that can be that you want to run before your container started. So those commands can be stored in terms of Docker file command lines, and they will be running once your container has started. So suppose you have Ubuntu Docker image, which is a minimal Docker image that you can store, that can use to run a Ubuntu container. But on top of it, you want to run a Java application. So we'll need to have a minimum JDK installed that can support that can give you a JVM environment, Java environment to your hosted application. So in that case, you can write some lines of code. By importing Ubuntu container, you can write some lines of code as per your application dependencies and build those Docker file to create custom container images. Once these images are built, they can be used like other Docker images, native Docker images, to run containers that will have all the dependencies pre-configured in your running container. So this is where Docker files are a very effective way to write your own custom images, container images that can be used by anyone, so that they can run your applications in containerized format. So this is all about components of Docker system. One important thing I would like to share here about Docker logo. If you go and check, Docker logo is like a ship, right? So this is called Docker. A ship can be called as a Docker. And why Docker? Because we are hosting containers. So the name of Docker came from a ship that is hosting lot of containers. So that's where you see the symbol of Docker resembles with the ship that is hosting lot of containers, that is that is loaded with a lot of containers and managing them. So from this place actually the Docker image came into picture. You have a ship Docker and that is used to place lot of containers on top of it for shipping purposes. Nice thing, right? So this is a good thing about Docker image, which actually shows the functionality in its logo that it is managing, right? So in next session, we will discuss about how we can install Docker on our virtual machine. We will have a Google Cloud instance, and there we will try to install a Docker. Okay. Till then, keep tuned, and let's meet in next session. Hi. So in last session, we have checked about various Docker components, and in this session, we will be covering how we can install our own Docker engine on our VM and how we can run various Docker commands on top of it. So for installing Docker, we can check on any website which gives Docker installation instructions, out of which Docker's own document is preferred. Docker's own document have installation instruction and lot of support instruction for all the features that Docker supports, and you can install you can get the instruction for any flavors that you want to install your Docker engine. It has documentation for CentOS, Debian, Fedora, Ubuntu, and even for Windows you will see instructions are available, like for Docker App, previous versions, Docker Compose, Docker Desktop for Windows. As I said, this is available here. So these all documentation you can find at one place on docs.docker.com. There will be various other websites, but for this installation we'll be referring this, and we are going to install Docker engine on Ubuntu. So as I said, I will be using my Google Cloud instance, which is a Ubuntu virtual machine. So I will just SSH it. Okay, so prerequisites like OS you need to have from these versions: Ubuntu Groovy 20.10, Ubuntu Focal 20, Ubuntu Bionic. So I have this version. So from Ubuntu 16, actually Ubuntu containers are Ubuntu supports containers. Architecture is needed this. If you have any old versions, you can install using this command. I have a fresh server, so I don't need to uninstall anything. For installing a fresh Docker engine on your machine, you need to follow from here. You need to set up your repository. You just need to update the repos in your VM. So for running these commands, I need to be a root. So I can use this, and from there I can run these commands. So even if I am using sudo, I do not need to be root. I can run this without being root also. I can be any other user. I can be Ubuntu. Okay, and again I can run this update. Sudo means super user. It will perform this command as a root. Once update of packages are done, I have to install these components in order to support my Ubuntu this Docker installation. What it is installing, you can see apt-get is the Ubuntu command to install apt-get is the binary command, and these are the, for installing we have install argument, for removing we have remove command. So these are options available with the apt-get command that you can go in more detail if you want to learn about apt-get. So for this install function, we will be installing using apt-get install, and these softwares will be installed. apt transport https, CA certificates, curl is to test web URLs, and GNUPG is to manage your GNU libraries. So just confirm yes, and it will do. So from any other user, if you are running this command, this user need to be part of your sudo file or sudo access, or you can say root group. Then only you will be able to these root commands using that user. So we can see these all packages are installed successfully, right? So next is I need to add Docker's official GPG key. Okay, so this is the command. What it does, it actually downloads this package from here using curl, and then run this against this. Okay, so this is how this command will be run and install GPG key. Once it is installed, based on your architecture, you need to check. Okay, so for checking the architecture, you can find this version. Okay, once this is done, I can update the softwares again, because I've added GPG keys and many other things. So I can run the update again, which will just refresh my repo. Okay, and then these softwares will be available to install after refreshing the repo. What I am installing here, Docker Container Engine. This is C, Docker's C, CLI, and container.io. These three softwares will be installed. Just put yes. Once this is done, you will be able to see Docker installed. So that is the minimum command I need to run in order to install Docker on my virtual machine or server. So this command may take some time. So we can get an overview here, like what we have installed. You just 3-4 commands we have run. Just update on the server repo. Then we installed these dependencies, apt transport https, CA certificates, curl as a binary to manage access URLs, GNUPG, and then we added this GPG key, and then we had to run this update to refresh the repo and install Docker main components. If you see here, the installation has completed. I can check Docker if installed or not. So if you see here, Docker version is 20.10 installed on my server. So this is all about Docker installation. These are very simple steps that you can follow from the documentation, and installation will be done. Since we have Docker installed now, we will be checking on demo, running our own commands, Docker commands to manage containers. Hi, in last session we saw about Docker installation on Google Cloud instance. Similarly, we can install Docker on any other server or machine. One important thing that we need to do as a post installation step, if you want to run Docker as any other user apart from root, because everything we perform using root and installation obviously we need to do with your root user in any Linux server. So running Docker commands need to have access to the Docker group. The user should be part of the Docker group that is created as part of the installation. So I have created one test user. Let me switch to that user and try running one Docker command, because I used my Ubuntu account to install Docker as sudo. So if I check here, is Docker pull and the image name you want to pull. I want to pull here Docker Ubuntu image, and you can see using default tag latest, and it has pulled in layers. These layers we will discuss later on. You can see if I do here Docker images is the command to list what images you have. Previously we didn't have any image here, and now we see one image is pulled successfully and can be listed using docker images command. Okay, so we saw this image as well. This command helps to listing all the Docker images downloaded on your system. Now, once you have Docker image downloaded, pulled from the Docker repository and available as in your local repo, we can say Docker registry. That is the where I'm able to list Docker images pulled already is in my local Docker registry. Okay, that's why I'm able to do Docker images list on that. So I can use Docker run and the image name. You see here, I'm not giving any container name here. I'm just giving Docker run command is used to run containers and the image name from where I want to run. Now what happens? Docker automatically assigns unique ID and a fancy name to this container when it is run without any name. ID will always be assigned automatically. That is kind of unique ID. So if I run this container using only Docker run, what do you see here? Docker command run successfully. Run successfully without any error. And if you see here, docker ps is the command run -ti. I'm giving terminal mode interactive, okay, and I'm not giving detach option -d, and I run this like this. So what happened? I started this container and I went inside it. I'm inside the container now, right? So if I see host name for this, I will see the Docker ID itself. Docker ID is the host name for this container. So what happened when I start without -d, it actually started the container in attached mode. I'm inside the container. Now this during automation this not be a good thing to go inside container and then do control exit or control D to exit the container. For that purpose, we actually use -d so that container can start by giving us a unique ID and end. And just give me ID and get back to the terminal. Not end actually. Again, it's still running, but I got it. I got my terminal back and container is running in background. So this container has started in detached mode and I can see the ID here, right? So what next? I can we already saw these commands like docker, and we saw docker ps -a to list all the containers, right? Whether they are stopped running. So if there is any stopped container, they can be seen by adding -a flag in the command. Next is docker execute. We already saw that if you don't give -d option detached mode, docker container will automatically log into the container inside, right? But what if container has started in detached mode? I want to log into the container. Then docker execute command will be used. Docker execute and give the ID, okay, of the container and command. If you are going to log into the container, this actually the last argument is the command that I want my container to execute. Okay, docker exec is the execute command. This will execute the command bash, and bash actually opens a shell inside the container. That's why we will be able to go inside the container. Okay, so I missed to give option TI here. Okay, so this interactive is important giving, because then only it will give me interactive shell. Okay, so I'm inside the container And if you see here host name, you will see the host name is the same as Docker ID, right? So every Docker container is assigned the host name as Docker ID itself. This is like a normal minimum OS only. The container is like a virtual machine only with lightweight virtual machine. Because I am borrowing it from Ubuntu server, Ubuntu image. This is a Ubuntu lightweighted server. I can run basic Ubuntu command here also. apt get update. If I run, it will run again, right? You see, this is running like a normal machine. So similarly, if you want to install any other thing, you can install inside Docker container itself. And by default, it will log in you as a root. You can type exit or you do Control D and you will be out of the container, right? This is how Docker execute helps us logging into the server. Then your container is done, your work is done, and you want to stop the container. How you can do? You can run docker stop and the container ID. Okay, and if you go and check, the container is not available here. It is stopped and will be available in docker ps-a option. See here. Okay. So similarly, if I want to kill any container, when there are two commands to stop the container. One is stop and one is kill. So if you check the difference, this command kills the container by stopping its execution immediately. This will not wait for any process to stop. This will not wait for graceful shutdown of the container. It will just forcefully kill the container and it will go in the stop state. The difference between docker kill and docker stop is docker stops gives the container time to shut down gracefully. Any transaction ongoing, any process is running, so it will wait for it to complete and graceful shutdown will be done. In situations where it is taking too much time, suppose docker stop is taking too much time, you can go for docker kill, which will forcefully kill the container and get you free from it, right? So let me start one more container and I go and check here. Docker ps will have a running container and I can pass docker kill and the container ID. It will stop, it will kill the container immediately. And if I go and check, there is no container and it will be listed in the stop container here, correct? So this is where you can use docker kill only when your docker stop command is taking a lot of time and you think you can kill the container forcefully. Now your work is done, your containers are of no use, you want to free some spaces, their stop container also occupying spaces. So you can opt to remove the containers using docker rm command. This command is again simple. You need to give only docker rm, then ID of the container, and it will remove it from the list. You see, the given container D025 is removed from the list. Similarly, I can use rm-f also. There is one case where you don't want to stop the container, you want to just remove the running container immediately. So there is one more option, which is the risky one also. Suppose I have a container running and rather doing two-stage cleanup like stop and then remove, I want to immediately remove the container. Then in that case, I can do rm-f, force removal option, which will remove the running container directly. Okay, so this container is running. If I want to remove it directly, I can do rm-f and this command, and this will remove the container directly without stopping it. Okay, so if you see here, there is no container running as of now. Similarly, because container image occupy a lot of spaces on server, so if the images are of no use or old, we can opt for cleanup of images also. So for that, there is a very simple command rmi, docker remove image. Docker rmi will be used, together. I can use to remove Ubuntu image. This is the only image we have. But if this image is being used with any other container, with any container in the system, whether running or stopped, you will not be able to remove the image with the normal command. You need to use force removal option. So before that, I need to delete all the images that are using this Ubuntu image. So this is the only one which is using this Ubuntu image. From here we can filter our images, which images are using this image that I want to delete. So pick the images that are pick the containers stopped or running that are using this Ubuntu image if you want to delete it, and remove the container first. Okay. You can give multiple container also here, like this. Okay. If you want to stop or remove multiple container, then you can do like this also. So this is done, and if here you will not see any stopped container. And now you can go and remove the Ubuntu image. It will be removed successfully. So let's see how we can create our own Docker Hub account. This will be needed in order to push your images on the Docker Hub. So you can go to Docker Hub website, dockerhub.com. This is a public Docker repository or Docker registry available on web. Okay, so I am logged in using mine, so I will log out. Okay, and this is the page. If you want to sign up, you can go here and choose a Docker ID that is available. Say I give Devops 123 demo. Okay, if I check this ID, you can give your email, you can give your password, and select this I am not a robot and sign up. So this will, once you opt for sign up, it will send a verification email on the given email ID that you give here, and from there you need to verify your account. Okay, so this is the steps mentioned here. Navigate to hub.docker.com. Okay, or you can see Docker Hub or dockerhub.com, both redirect to same URL, and then sign up on the website, agree on terms and conditions, sign up. Okay, the mail and the password that you have used. Once you have verified your account, you can log in using the given account name and password. Once you have verified your account, you can go to sign in. Okay, and in sign in you can give your Docker ID. I can give here and give your password, and it will take you to the Docker Hub repository. Okay, so this is all repositories that I have in my account. Similarly, you can browse for any other public repo available here. You can see a lot of public repos are available here, right? You can check for Ubuntu, Nginx, MySQL. Okay, you will see, like for Ubuntu, if I search, you will see lots of Ubuntu images available from various publishers. Okay, suppose you want to check for MySQL images, you can go and check. You will see MySQL official, MariaDB, lots of flavor. Means you can post your own flavor on this portal, this repo, and this way this will be these all repos I can download on my server and use it. Suppose I want to download MySQL, I can go here and you will see a lot of versions available. This actually when we do Docker pull MySQL, we do not give any version. So by default it takes latest. You go and check on tags here. So there is one latest. So if I don't give any version or tag here against the image name, then it will by default pull the latest tag image. By default it will be downloaded. Suppose I want to download this this MySQL image, tag number, version number you can say, or anything. This is basically a version related to tag. So this you can use like docker pull MySQL colon 8.0.23. So in short, if I say any image, if you want to download with the tag, you need to give docker pull image name, say MySQL colon tag number 8.0.23. Okay, and it will check for the existence of this image and tag on the public Docker Hub and download it. Even for local private repo also, registry also, you can perform the same step. If you check again Docker image downloaded, you will see this image is available. Just download it, right? So this is how we can manage our repos. We can create a Docker Hub account and download repos from there also. So in next session we discuss about committing changes to our running container. If you want to save, if you have made any changes to a container, you can save those changes to that particular image also. You can modify that image also by committing changes to the container, and that's what we will be discussing in next session. Till now we have covered virtualization, containerization, what is Docker, Docker installation and the components of Docker and Docker lifecycle. We also saw how we can use some of the Docker commands to manage our containers. In this session, we are going to run one container, and we will see how we can run any changes made to the container, running container, to the Docker container image, so that the changes we have made to the container can be saved in form of image and can be used as is to launch configured container, or the container that is modified by us as per our requirement later on. So any changes we do on running container can be saved using Docker commit. That's what we are going to see in this session. What we will do, we will try to accomplish the following example with a container and see how we can commit this container into an image. Okay, so we will use a Docker container, Ubuntu container, and it is a core Ubuntu container which do not have any component installed on it, like Apache, WebLogic, application server, Tomcat, anything. It is not installed on top of this Ubuntu container. What we will do, we will do customization on this container and install Apache server on top of it by going inside to the container. Once Apache is installed successfully, we will commit the changes to the container, and what we will see later on, we have a Ubuntu Apache image as a result of this operation created. Okay, and this image can be used to launch a container which is Apache enabled automatically. Okay, so let me launch my server that is on Google platform, already running. So I have already launched. Let me connect to it. So let me see if I have Ubuntu image available, or I need to pull it. Docker, let me change my user first. Docker images, right? Now we have learned already about this command. So I don't have Docker Ubuntu image. So what I will do, I will pull. So it is not necessary to pull the image before you launch the container. Even I can run the container directly without pulling the image. So let's do that way. What I will do, I will run the container without pulling the image, and you will see here it will automatically pull the image that are required to run the container, whether that is one container or there are multiple container involved. So the command is docker run -ti-d and the image name. So you see, and what it says, unable to find the image ubuntu:/latest locally. So it has pulled, and if I see here, not only pulled, it has started the container also. You can see the container, Ubuntu container, has started 7 seconds ago. Right, fine. So we are done pulling and running the container as per the slide, and now what we will do, we will go inside the container so that we can do changes inside it. What changes? We will install Apache inside it so that we can have Apache enabled container. How we can log into the container? Docker execute command -ti, the container ID or name, and the command will be bash, because we want to execute bash command to open a shell for us. And you can see by doing this we are inside the container with root user. Okay, so what's next? We can run this command. Now this is like a normal server. What I can do, I can first run update, because I am already root user, so I do not need to put sudo. I can just run apt get update first of all to refresh my repositories, to download package updates from Ubuntu server, and then I can install apt get the command and install. What to install? Apache. Okay, it's asking me whether I am sure to continue or not. So I will say yes, and it will install Apache on my container. Okay, so it is asking me my region. My region is Asia. Time zone is what is this? Kolkata, it should be right. Yeah, 44. So we see installation of Apache is done successfully. What I can check, I can check if Apache is installed here. Grab Apache. See, Apache is installed now here. What's next? We have done the changes. What we will do? We will come outside the container. Okay, I need to come outside the container by doing exit, and I can do docker commit and the container ID. So first I should get the container ID docker ps. Okay, and what is the command? Docker commit and the container ID. And now, because this is a new image, I'm not changing my Ubuntu image, I'm creating a new image with the updated container that is running already. So what I have to do, I have to give a name to the container that I am going to save the changes or create a new image with the saved changes. So for that purpose, I need to give my docker, I need to give a tag and then image name. Okay, so first thing that I need to give, I can give any name to it. Okay, first of all I can give docker commit and image container ID and say Apache Ubuntu. This is the image name I gave. So what it will do, it will save image with this name docker image. If I do so, I will be able to see my latest image that I committed. This is the command to save this container. So the committed changes are saved as Apache Ubuntu. But remember, I have not given any tag here. So if I try to push this image, that we will see later on. So we will see like see request access is denied, because whenever I am saving an image locally, I am creating a custom image, I should give username slash image name. That's why from the first variable that I give in the name before slash, it actually identifies the username. So that is required in order to let the Docker Hub know when you are pushing. Then it will let your container registry know to which user account you are going to push your image on the container registry. That's why if you see here, we need the exact command looks like docker commit container ID, username and container name or image name, I will say. This is not container name, it will be image name. Okay, so this is where I need to commit, and I should give my username, Docker Hub username that you have created in the previous session. Okay, this should be your user account or username on Docker Hub. So if I list here, there will see two images now, one without username and one with the username. So this is correct one. In the next session, we will see how we can push this image to the Docker Hub. So this is all for this session, and let's continue with the next session onward. So as we see in last session, we have committed some changes, like installed Apache and committed the changes to Ubuntu container. And that's how we created one Ubuntu Apache enabled container, or we can say not container. We have created one Apache enabled Ubuntu Docker image. Okay, so let's see how we can push our custom images or created images to Docker Hub using our Docker account. So for that, we need to actually log into our account first on our local machine, whether it is desktop or any cloud instance or any virtual machine. We need to first log into the Docker Hub account. So let me go to my server and this is my server. Q Docker logging here. You see, login succeeded here. And what's next? I can, once I'm successfully logged in, so I can try pushing my container to the Docker Hub using this command, docker push, and the username slash image name or image ID or container ID. It should be image ID actually. You will not be pushing the container, you will always push the image on the Docker Hub. So if you remember, we have saved with the same pattern, username slash image ID. So what we will do, we will check we already have this. So this image with username slash image name or image tag need to be pushed onto the Docker Hub. So I can do docker push and this image name, and it will push successfully into my Docker Hub repository. It is pushing, you see, it is pushing. Actually, this all IDs you see here are layers actually. So these many layers exist in this image. Okay, one layer we added, sorry, no, we have not added any layer because in Docker commit we do not add layers. These are all layers added by Docker file that we'll be learning in next session. So whatever commands you run to execute your Docker image building or Docker image build, these actually create layers in the Docker images. They are stored in form of layers and they are downloaded individually. Okay, so this is the basic difference between Docker commit and Docker build. Whenever you do Docker build, actually it actually picks all commands from the Docker Docker file line by line and add layers for each line of code you have added add on command in the Docker file. While when you do Docker commit, it do not add a layer to the container, it just saves the changes in the existing image file or still existing image. So this is how, if we see, I have successfully pushed my image onto the Docker Hub account. Let me go there and log into Docker Hub. Okay, and you see, this is the recent image that I have pushed to my Docker Hub account, updated 1 minute ago. If you go here, you will see one tag only available because we have just pushed one version of the image. So you see only one tag here, latest available. We have not created any version tag explicitly. That's why you see only latest tag available for this image. And here also locally you see latest tag. So that is the same have been pushed onto the Docker Hub account. What if I try to run this container now using this image? If I try to run any container with this image, so you can remember like what was the ultimate purpose, to have an Ubuntu image, Ubuntu Docker image that is already Apache installed. So let's verify the same. What we can do, we can run a container again using this custom image now that we have created. And what will be the verification step? We will see this image will already have Apache installed and we do not need to install any additional Apache component on top of it. Run it and you see docker ps will give you, okay, so now this container has started with the image that we created, not from the Docker. Okay, so let's log in into that. Docker execute -ti container id and dash. We are inside the container and let's see if this container already has this Apache installed. You see, so this changes we made in the running container, we committed the changes, and when we use the image that is created by committing the changes can be used to run any new container with the saved changes directly. We do not need to configure containers again and again, and this is a very good feature of Docker which makes it favorite among all the container supporting tools. Okay, so that's all about Docker push and Docker commit in this session. I have shown you this. Next session we'll be discussing about Docker file, which is again a very important topic which helps you understanding how you can create your own Docker images from scratch as per your own development or environment needs. So we saw in last session how we can make changes in the existing Docker images. But what about if we want to create our image from scratch? That's where Docker file comes into picture. What is a Docker file? It is a text document that contains all the commands a user could call on the command line to assemble an image, to bake an image. Using the Docker build, users can create an automated build that executes several command line instructions in succession. So the commands that you write in Docker file are executed sequentially, and that's where each command adds layers to the Docker images. So there are some important components, keywords that Docker file supports, and you need to use them while you are building a Docker file. So the first one is from keyword. The from keyword is used to define the base image. Means you need to have a base image on top of which you want to add your commands. You want to register your changes. So the from keyword is used to define the base image on which we will be building. So we need a base container, base image that will run and support our further command execution. So that's like example. If you see here, we can write from and then the image, and if you want to specify tag also, version also, then Ubuntu, the image name colon image version or tag number. Then the next comes add keyword. The add keyword is used to add files to the container being built. If you want to add any file present locally on your desktop, on your local server, local file system, you want to mount or add those files to the container, then you will be using add keyword. The syntax will be like add the source location and the destination location in the container. This will add files from the current location to the destination location while building the image. So these images will be part of your image now, and you can see when you launch your container. Then comes run keyword. This keyword is used to add layers to the base image by installing components. So if you want to run any command inside your container during image build, then you will use these commands along with run. So this will notify containers that these commands need to be executed during Docker build or image build. So each run statement adds a new layer to the Docker image. As I said, any run statement any statement that you write, any command that you write along with run will add a new layer to the Docker image. That's where you see when you download any image, you see lots of layers being downloaded, and that is called layered image structure. So how you can do it? You can write any command like run, and then the command add apt get update to update your Ubuntu container. The same command we ran manually when you did Docker commit. Now you can write same commands in form of images that will run automatically during Docker build, and then you install Apache inside it. We are doing same command, the same example we are implementing using Docker file now. So that's where you see you did run Apache update, run Ubuntu server update, then run Apache installation on top of it, and then add some files, some HTML files that you may have that you want to run on top of Apache. So you will place those files from local location, local folder to var www.html, where you will be in var www.html folder we actually place HTML files that we want to access inside Apache web server. So that's how we are doing three things here: from, run, and add. Next is cmd keyword, that is used to run commands on the start of the container. Your image is built, your container has started. Now once container start, what first command you want to execute during container start? Similarly, if you see here, we were giving like docker execute when we run here, this one. So we were running bash. So this was the first command when this container was starting, this command was running. Similarly, which command we want to run when our container starts is mentioned by cmd keyword. These commands run only when there is no argument specified by the container while running the container. So actually, whenever, suppose I am running this container Ubuntu and I do not give any command here, so this will run with the command given in the image by cmd option. So, but when I give a command here, it will override the cmd, and cmd command will, the command provided in the cmd section will not run. So whenever you want the commands that you are placing in the container start step, you want them to be replaceable or overwrittenable, then we will use CMD option. So here, if you see, we have given a command Apache CTL -D foreground. We are starting Apache CTL as Apache Cuttle to start the Apache services. So that's where we are running in CMD. Then comes entry point. Entry point is similar to CMD. That is again used to run commands the moment the container initializes. The difference between CMD and entry point is entry point will run irrespective of the fact whether the argument is specified or not. That means entry point commands are not overwritten. They will always execute whether you provide anything during container start, like when you are doing execute, or if you are not providing, again it will do the entry point commands run always. So that means CMD commands can be overwritten while entry point commands will not be overwritten. They will be always running and they will be always present during the container start. Then the last is env keyword. There are many, but we are focusing on the important keywords only here. The env keyword is used to define environment variables in the container runtime. Suppose you want a server to have some environment variable initialized, like we have variables initialized in Linux servers, Windows servers, we have environment variables, user variables, system variables. So these are environment variables that are available to the system to use by application or by the server itself. Similarly, if you want some particular keywords, some particular environment variables to be available after container start, like username, password, or some other variables that will be used by your applications, Apache or application servers, then you can mention them in environment keyword. So like we are mentioning environment name, we are mentioning name as a key and we are providing value Devops tutorial as value to it. So name is an environment variable here and Devops tutorial is the value to this environment variable that we can access after container start, and that will be persisting, that will always be available during the container run until overwritten. Okay, so these are the keywords in Docker file that we have seen. So next we will be covering to create one sample Docker file the way we had discussed right now, and we will try to run this sample Docker file in the next session. So in last session we saw what is Docker file and what are the important keywords that we can use while writing a Docker file based on our need. In this session we will see the demo of same, how we can write our own Docker file, and we will try to write a Docker file for our use cases that we have discussed already. Similarly, we will install one Apache 2 software inside Ubuntu base image, and we will mount some our custom image file, HTML files that we want to run inside Apache, and then we will use entry point to start Apache CTL. Using Apache CTL, we will start the Apache service in entry point. Okay, so this is, and then we will set one environment variable name that we will check if reflecting as an environment variable or not after container start. So this is all we are going to do in this session. So let's create one folder. Create one folder Docker. Let's go inside it, and here we have nothing, so we will create one Docker file. So what's next? We can create one Docker file using this content. I have one file here. So for the sake of time, I will just copy the content I already have here. This is the one that I am going to use. Okay, so let me create one Docker file. We can use a custom Docker file name also, rather use this Docker file with capital D is standard name that we can use for our Docker file, but we can use any name and we can provide with the -f option also. And we can use any location also to specify using -f option when we are doing Docker build. So this is a standard using capital D Docker file, but we can use any other name also. So you see, I have used base image in from tag, from keyword, then environment I have set variable as time zone Asia Kolkata, because this Apache installation needs some environment variable already set. So I am setting my region and time zone here. If you see, we selected manually during the manual install of Apache during Docker commit session. Okay, same way I am specifying here in the environment variable so that our Apache installation can pick this variable automatically, and I do not need to specify user input. Fine. So this environment variable has been provided in this run command to the time zone. Okay, local time. So this is I am updating here this time zone to my local time zone here. Then I will run Apache, Ubuntu apt get update to update my repo, and then install Apache, and then add files located in. I will place some files in my local folder, and I will mount these files to the Apache image in where www.html location, so that I will display my own HTML page on the container. Okay, so this is all I am going to build in this image. And what's next? So once we have this this Docker file created, I will create my HTML page also. Okay, so that's what I said. I will need one index.html or create this index.html or if placed in where www.html folder of Apache, the Apache picks this file automatically to display on the Apache web page. So let's put our own content. This is a simple HTML file. You see, HTML started, title I gave sample website, and body content I gave hello world. So when I run this page, it should the Apache should display this hello world on the web page. Okay, this is my index file, and now I have my Docker file and index file ready. So this is my current folder. If I do ls-ltr dot, I am mounting dot folder. Dot means current directory in Linux term. Okay. So if I do this, so you see I have two files. So this way I am mounting my dot index.html to Docker file or Apache location via www.html. Okay. So this is done. This is done. Okay. What I will do now? I will build my Docker file. What is the command? Docker build the directory of Docker file. If I have any other place I have kept my Docker file, so I will specify the location here, and -t name of the image. -t is the name of the image which I specify along with user tag also. So okay, so in -t I can give user name / image name, or I can directly give image name. Both will work. Okay, if I want to push the image to Docker, definitely I need to give username / Docker file. Fine. So let's build. Because I am going to mount this file docker index.file to the folder, so that also need to be present. So let's run Docker build. The location of Docker file is here in present directory, so I can mention dot also. And by default, Docker build looks for Docker file with this name only, capital D Docker file. If I have mentioned any other name, then I need to give -f option to provide the explicit file name. Then -t and the Apache Ubuntu I am creating. Let's see how if this build is. So you see the Docker image is getting built from Docker file, and you see it steps getting run here. I will show you that also. When I started building, you see steps. Whatever lines I have written here, they are considered as a step during the Docker build. The first one was from Ubuntu, then second one was environment, I said. Third command using run, I executed this command. Then fourth was running apt get update. Total commands were 6, and if you see seventh Then this apt get update done, updating repo of Ubuntu, and then fifth command was to install Apache. Everything is getting displayed in detail. And the eighth command was, sorry, sixth command was setting environment variable. So these all output are for installing Apache. This is a long output that you will see again on console itself. And the sixth is adding my file to the uh, where www HTML page. Okay, apart from this, I think I forgot to add one environment variable also. I think I missed this. Let me. Yeah, so two things I missed here. Yeah, this and this. So let me add this and build again. So I will update my Docker file and I will append these two lines also. Fine. So
Yeah. Ya, అందులో చూస్తారా గోధుమ సెపరేట్ పెట్టలేదు తెచ్చుకోమలా క్యాబేజీ బీరకాయ బీరకాయ Ah, ahora vamos. Vale. Vamos. Next bar again. కాల్ పిచ్చు కాల్ కాల్ ఇంతనా ఆగాలి 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 ఇవ్వాలి ముక్కు ఇచ్చా
ఏం చేస్తున్నా
చాలు చాలు ఇంకా వచ్చి వద్దులే ఆర్డర్ అయిపోయినాయా
So, so that Apache can start. Let's run the build command again. It will just execute the difference step. Now see, image was built already and it did not give the long output because these other steps were already executed. Additional steps 7 and 8 executed as part of changes in the Docker file. So this is how Docker remembers the history of execution and only adds the differences and the changes for the changes you have done. So let's check if this image is available here. Docker images. So you see this image that I built just now is available here in the main settings account. Okay. So this where I can see my image is ready and I can run it also to see if my container image is working fine. So what is next? Docker image is built, and now the last thing is running the container from the image I built. Docker run -ti -d and give the image name. Docker container has started. Let's see, this is a recent container just 4 seconds ago. This is the container ID, and if I go here inside docker execute pi, and let's run the test now. What changes I did, what I wanted to be present inside container. First thing was files that I mounted to where www.html ls-ltr. Just check the files here. You see, we mounted our current directory which had docker file and index.html to where www.html of container, and it is successfully mounted and I can see my file here. Second was environment variable. What was the environment variable name? $name. If I check this, it is already also present successfully inside the container and I can access it. And when I do echo, it is showing the value of the environment variable that I set during the docker build. Okay. And third thing was Apache. Let's check if Apache is running. Let's restart it. See, Apache Kettle open foreground we run, and this process is running well inside the container. Third is to check if the file index.html is accessible on the Apache port. Okay, so to mount this container to some port, we need to actually okay. So in order to mount the container to some port, we need to do port mapping also, and that's where something new we will see to mount the container to some image port. Okay, so that's the step we need to do additionally if you want to access my container outside, okay, from host port. So let's see how we can do. First, I will show you the services running inside the container. Since we have started Apache, so by default Apache runs on port 80. Okay, so that port 80 we can see is accessible or not using curl local host :80. Curl is not found, so we need to install it. Install curl. This is installed and we can check now, and local, oh sorry, this is spelling mistake. See, so my HTML is well accessible here inside the container, but what if I want to use this port, I want to access this port outside the container? Can we do it? Let's see. Curl http localhost :80. Try this and you see connection refused. From localhost, I am not able to access the port inside the container. For that, there's one additional, there's one advanced concept comes into picture, that is port mapping. That is part of the advanced Devops training session. But here I will show you how you can do it. For porting a host port, for mapping a host port from host port to container, we use -p option or -- port option, and it is like how it is done. We can start a new container out of the Ubuntu image that we started, this one, and we can do port mapping. How? Using -p. Local port 81 to container port 80 in order to Make container services accessible outside the container from host. Okay, so let's run this, and you will see a new container started, which is just 2 seconds ago, and we can log in. We can try accessing our services inside it. You don't need to go inside container. You should be able to access outside the container also, because we have mapped. You see ports mapping here in this ports column also. So our local host 0000 colon 81 port is mapped to the port 80 of type TCP inside the container, and that's where I'm able to access container services outside the container from host itself. And even if this host IP is accessible publicly, I can access it from the web as well. Let's go here, and this is my uh, containers. This is my server's public IP. Okay, and because I have not exposed it for HTTPS outside, so I need to make some changes here. I need to edit and I need to enable HTTP and HTTPS, or I need to do some firewall settings. Okay, so this option I can enable, and this will allow me to access HTTPS traffic or HTTP traffic from this server itself. This will open actually firewall to the server for port 80 and 443 for HTTPS and for HTTP and HTTPS respectively. Okay, so these changes are getting saved. Once these are saved, I will be able to access host on public IP also. This is my IP. Let's run this. So I can do HTTP colon IP colon 81. You see, this HTML page is well accessible outside the server, also using public IP of the server. So this is what we can see. We have bundled an image, we mapped some our custom index file, HTML file to the Apache, and able to run this successfully over the internet on Apache web server. So this was our exercise, and this is all about Devops Docker training session. Next session, we will start some more interesting topics. Till then, keep tuned and keep learning. Bye.
ఈయన ఎలా ఉండితే రేపు వదులుకుని ఉంటాను ఎవరు పెట్టుకుని వదిలేసాను అనుకో కింద తడికి లైట్ గా చమ్మొచ్చు అయ్యో పోయింది వాళ్ళేమో పనులుగా ఎప్పుడన్నా మాట్లాడాలంటే నీళ్ళు కలిసి పెడతారు ఆ వాటర్ వస్తుంది కదా